A very good afternoon to one and all. My name is Dr. Vishalli and I'm working as an assistant professor in the Department of BSc Computer Science at IIMT College of Science and Technology, Greater Noida. The topic of today's presentation is Clipper circuits. So let's begin with this presentation. First of all, a brief introduction about the Clipper circuit. What are the Clipper circuits? So we all know about the PN junction diodes. So diode has a property that is called as a unidirectional property, in which we can say that in the forward biasing, the diode conducts, and whenever the diodes are in reverse bias position, then they are said to be in the cutoff position, or we can say that the negligible amount of the current flows through the diode. Due to this property, diode has found many applications. Some of the applications are clamping circuits, voltage multiplier, and clipper circuits are also one of the applications of the junction diode or PN junction diode. So, what is the purpose or what is the function of the clipper circuit? So, a clipper is a circuit with which the waveform is shaped by removing or clipping a portion of the applied input signal waveform without distorting the remaining part. So as the name suggests, clipper means it clips out or remove the certain portion of the input signal or applied input signal waveform without disturbing or without distorting the remaining part of the waveform. For example, in a waveform, if we have a certain noise or something which we don't require in that, then we can simply clip out or remove that portion with the help of the clipper circuits without damaging, without distorting the remaining part of that waveform. Clippers can remove signal voltage above or below a specified level. That level can be specified and it removes the signal voltage above or below that level. Clipper circuits have found extensive use in radar, digital, and other electronic systems. It has also found applications in communication system, especially where we have the noise pulses. So, with the help of the clipper circuit, we can basically remove those noise pulses above or below certain specified level. Although there are several clipper circuits have been developed, not only diodes, there are apart from diode clippers, we have several other type of the clipper circuits. But for this presentation, we will confine our attention to only the diode clippers. Apart from diode clippers, we also have the transistor clipper, which are also the nonlinear clipper. But for this presentation, we will basically discuss only the diode clippers. Clipper circuits are also referred as the voltage limiters, amplitude selectors, or slicers. So these are just another name, but mostly used name are the clipper circuits. So according to the level of clipping, we can classify the clipper circuits into four types. First is a positive clipper, negative clipper, biased clipper, and combination clipper. For the clipping circuit, for this circuit actually, we require two components. One is a diode, as this is a diode clipper, and second is a resistor. And sometimes we also use a DC battery for fixing the clipping level. And on further, what we are studying, we will consider our diode, which is in the circuit, as an ideal diode, because then ideal diodes mean the diode which acts as a closed switch when it is forward bias, meaning it is fully conducting in the forward bias position, and it is an open switch in the reverse bias. Means that no current flows through the diode when it is in the reverse bias. So now we will study one by one all these four types, and for all those types we will consider that our diode is a ideal diode, that it is conducting in the forward bias and it is completely non-conducting in the reverse bias. So the first type is a positive clipper. So as the name says, positive clipper, we are basically representing our input wave like this. This is a sinusoidal wave. It has two half cycle. One is a positive half cycle, another one is a negative half cycle, and this V is its peak voltage. So positive clipper, what it does, it removes the positive half of the cycles of the input waveform, and it can further be divided into two categories. One is a series positive clipper and another one is a shunt positive clipper. Again, in all those circuits, diodes are assumed as a ideal. that it works as a closed switch in forward bias and open switch in the reverse bias. Now let's try to understand how positive flipper removes the positive half cycles from the input waveform. So for that, we will first consider the series positive flipper. So consider this figure A and C. So in the series positive flipper, as you can say, this is a diode. So series positive flipper, the diode is basically in series with that of the low resistance. And in the shunt positive flipper, the diode is basically in parallel with that of the low resistance. So in the series positive flipper, this is a diode B. R is a resistance output, VO is obtained. VI is the input voltage or input signal is applied across this. So during the positive half cycle, this end will be, the upper end will be positive and the lower end will be negative. So we can say that N is connected to positive and P is connected to negative. So now this diode will be in the reverse bias position. So whenever the diode is in the reverse bias position, we can say that this will be non-conducting, the diode will be non-conducting and it will act as an open circuit. So when this diode is an open circuit, all the voltage will be appearing across this diode and there will be no voltage across the resistor R. So the value of VO or V output will be 0. So you can see clearly during the positive half cycle, we have applied this input with peak value V, but we are not getting anything in the output. So we can say that the positive half of the input wave has been clipped, it has been removed, right? So next, during the negative half cycle, this polarity will get reversed. The upper end now will become negative and the lower will become positive. In this position, N is connected to negative and P is to positive. So diode will become forward bias. So whenever this diode will become forward bias, it will act as a short circuit or as a closed switch. When this will be acting as a short circuit, the current will start to flow and there will be the voltage drop across the resistance R. And in this situation, we will get the output voltage. So output voltage is being represented in the in this diagram. This is the output and input waveform. So we can see clearly from the series positive clipper that during the positive half cycle, the positive part has been clipped or has been removed, but the negative half cycle of the input waveform is reproduced in the output waveform. Right. So that was about the series positive clipper. Now we'll discuss the shunt positive clipper. So this diagram B, it is showing the shunt positive clipper. The for input and output curve, I'm again considering the figure which is represented in C. So now let us consider these two images, that is B and C. Again, now during the positive half cycle, now you can see clearly that the position of the diode is changed now. Now the output is being obtained across the diode. So this is the input signal. Again, we will consider the two half cycles. During the positive half cycle, this diode will be forward biased and during the negative half cycle, it will be reverse biased. So during the positive half cycle, it is when it is reverse biased, then this diode, it will act as a short circuit or closed switch. So voltage drop across the diode will become 0. All the voltage will be dropped across this resistor R. So we will get VO as equal to 0. There will be no voltage drop across the diode B. So during the positive half cycle, in the output, we will get no wave. So there we can say again that the positive portion of the wave has been clipped. During the negative half cycle, this will become negative and this will become positive as the polarities are reversed. So in that case, the diode will be in the will become reverse bias. Reverse bias means it will act as a open switch. Whenever it is acting as an open switch, all the voltage will appear across the diode and hence we will get the output voltage. So again, in the negative half cycle in shunt positive flipper, we will get the output waveform and this process continues. So we have understood that how by using this positive flipper, whether in series or in the shunt positive flipper, we are getting this kind of the output in which the positive half of the waveform is removed and negative half of the input waveform is retained in the output. So that was about the positive flipper. Let us understand this further by considering an example. So this is given waveform, this is input waveform, and this is a shunt positive clipper circuit. So let us find the value of the output voltage. That what will be the shape of the output voltage and how it will be input signal will be reproduced in the output by passing through this clipper circuit. So this is the input waveform with peak value 10 volts. During the positive half cycle, this will become positive and negative. So the diode, it will be forward biased. Now if this diode is forward biased, it will act as a short circuit. It is shown in this diagram. It will act as a short circuit and the current will start to flow through it. When it is acting as a short circuit, then there will be no voltage drop across the diode, and hence there will be no output voltage. So during the positive half cycle, we don't have any output voltage. Now let us consider the next half cycle, that is a negative half cycle. During the negative half cycle, these polarities will get reversed. Upper end will become negative and lower will become positive. Now in this situation, this diode, it will act as an open circuit. So whenever it will be acting as an open circuit, voltage will appear across the diode. Now let us calculate that value of the voltage. When this diode is an open circuit, then this R and RL, they will be in the voltage divider position. So we can calculate the value of the output voltage by using this relation. So the value of VO, it is coming out to be -8 volts. So what will be the output? Now this is an input waveform. In the negative half cycle, the value was -10 volts, and in the output waveform, we will get the value as a -8 volts. And the positive portion of this waveform will be completely clipped. It will be removed. So that is how we can understand the positive clipper circuit. Next is the negative clipper circuit. Again, on the same lines as positive clipper circuit, removes the positive half of the input cycle. The negative clipper, it removes a negative half of the input voltage waveform. It is just like we can say that we have already studied in the half wave rectifier. The input and output wave of the half wave rectifier is just like this. So again, as we have divided positive clipper, negative clipper can also be divided into two types. One is a series negative clipper, another is a shunt negative clipper. So first of all, we'll study the series negative clipper. So we'll consider diagram A and C. So in the diagram A, this is now during the positive half cycle. This upper portion of this image C is the input waveform, and the lower one, this is the output waveform. In the first positive half cycle, again, this polarity will be like this, that the diode, it will be in the forward bias. Now the diode is in the forward bias. Now if it is a forward bias, then this diode will act as a closed switch or the short circuit, and voltage drop across the diode will be 0, and the voltage will be drop across the resistance R. So we will be getting some value of the output voltage. So this is the input waveform. This is the output waveform in which we are getting the output in the positive half cycle. During the negative half cycle, the polarities will be reversed, and this diode, it will become reverse bias. Now, when this diode will become reverse bias, again it will act as a open switch. All the voltage will be dropped across the will appear across the diode, and there will be no output across the resistance R. So we will be getting no output in the negative, corresponding to the negative half cycle of the input waveform. The same is the case with the shunt negative clipper. Again, we will consider diagram B and C. During the positive half cycle, this diode, it will become reverse bias. Reverse bias means it will act as an open circuit and voltage will drop across the diode. So we will be getting the VO or the output voltage. And during the negative half cycle, this diode, it will become forward bias. It will act as a closed switch, and the voltage drop across the diode is 0. So there will be no output voltage obtained in this circuit. So we will getting no output in this negative half cycle. So again, we will consider this example to understand this further. So consider this is a negative shunt capacitor. It is similar to that of the positive clipper. So this is a negative shunt capacitor, and this is an input waveform which is applied. So we have to find the value of the output waveform. Again, we will consider the two cycles. During the positive half cycle, this diode will be reverse bias and we will get the output. And during the negative half cycle, this will become forward bias and there will be no output. So we can calculate the output voltage in the positive half cycle. Again, this is R and RL, it will become a voltage divider. And by using this relation, we can calculate the output voltage. The peak value of basically the output voltage. This is coming out to be 8. So this is the input waveform and this is the output waveform of the positive half cycle. So this is how we will get the output. And in the negative, as the diode is short circuit, we will not get any output across the, we will not get any output. So in the negative half cycle, we will not get anything. The negative half of the waveform will be clipped off. So we have now understood how to remove a completely one half cycle of a waveform by using the positive and the negative clipper. But one thing is to note that which I have already discussed, that the diodes which we are considering are the ideal diode. We are considering that our diodes are ideal, that it is completely conducting in the forward and it is completely cut off in the reverse bias. But in actual situation, it is not like that for the practical diode. If the second approximation for the diode is considered, then we know that a barrier potential of the diode is already there. The value of this barrier potential is 0.7 for the silicon and 0.3 for the germanium. If we take these barrier potential also in the account, then the waveform of the positive and the negative clipper circuit, that will get slightly modified. So this is the output waveform will look like in the positive clipper, and this is for the negative clipper. This portion of the voltage, this is basically this barrier potential V naught, which is 0.7 for the silicon and 0.3 for the germanium. So this first image, this is the output waveform for the positive clipper, and the second image is a output waveform for the negative clipper. The third category is a biased clipper. Now we have there must maybe some requirement in which we do not need to remove the whole positive or whole negative half cycle of the waveform, but we need to remove a small portion of the negative or small portion of the positive half cycle. So in that case, when we have this requirement, we will use a biased clipper. So bias clippers can also be categorized into the four types of positive bias clipper, bias clipper with reverse polarity, negative bias clipper, and negative clipper with the reverse polarity of the battery. So up to now, in the case of positive and negative clipper, we have used diode and resistor. So now in the bias clipper, we will also use a biasing potential, or we can say that the battery voltage in addition to diode and resistor. So first of all, we will discuss the biased positive clipper. Again, it has also the two types, series and shunt, depending upon whether we have placed a diode in the series with the load or in the parallel with the load resistance. So first of all, this is biased positive clipper. So we can say that the circuit is almost similar to that of the positive clipper. The only thing which has been which is being added is this VR. This is a battery voltage, the additional DC voltage which has been applied, which is in series with that of the resistance R. So let us now see what how this VR will affect the final output waveform. So first of all, we will consider the series biased positive clipper. This is we will consider diagram A and C. This is the input waveform, which is a complete sinusoidal wave, and output is shown by the solid line. Input is shown by the dotted lines. So series positive clipper, we will start with the positive half cycle again. Now, during the positive half cycle, now this diode, it will become reverse bias. And if we see this potential VR, this is a fixed DC voltage. Say its value is 5 volts or 2 volts or 3 volts. It's a fixed value. And if we see VR, according to VR, this diode is forward bias. And as per VI, this diode is reverse bias. Right. So now Whenever the value of Vi is greater than VR, then there will be no output corresponding to the input wave. Why it is so? Because as per VR, this diode is forward biased. Forward bias means it will act as a closed switch. If it is a closed switch, then the current will flow through this circuit and we will get the output. Initially, the value of Vi is lesser as compared to VR. So, whenever the value of Vi is lesser than as compared to the VR, then there will be this diode will be forward bias and there will be current in the circuit. Whenever there is a current in the circuit, we will surely get the output voltage. Whenever this value of Vi exceeds VR, then this diode it will become reverse bias. Once this diode becomes reverse bias, it will act as a open circuit. Open circuit means the voltage will appear across a diode and there will be no voltage drop across a resistance R. So that's why VO will be equal to 0. So you can see clearly from 0 to VR, we are getting the output. But once the input voltage exceeds VR, we are not getting any output. So we can say that up to above certain level, the input waveform has been clipped off. The portion of the input waveform which lies in this region has been clipped off or has been removed. Now let us consider the second half cycle, that is a negative half cycle in the series biased positive clipper. During the negative half cycle, this diode will become forward bias, and as per this is already forward bias. So the diode is always forward bias in the negative half cycle. If it is forward bias, there will be current in the circuit and we will always get the output voltage, or V0 will always be there. So in all the voltage which was in the input has been has been reproduced in the output. So we'll get the output waveform on the screen. So this is overall output. It will look like in the positive half cycle, the the portion of the waveform above VR has been clipped off. Remaining wave has remained the same. Remaining input wave has been reproduced in the output waveform. So I hope you have understood this now. So that was about the series biased positive clipper. Now let us try to understand the shunt biased positive clipper. Again, the circuit is same as that of the shunt positive clipper. We have applied just this VR battery potential in series with this diode. Now again, we will start with the positive half cycle. During the positive half cycle, this diode is in the forward bias, and as per VR, this diode is in the reverse bias. As long as the value of VR is greater than Vi, this diode will remain in the reverse bias position. Reverse bias means this diode will be short circuit, this will be open circuit. If the diode is open circuit, then all the voltage will be appearing across a diode and we will be getting the output. Once the value of Vi exceeds VR, the diode will become forward biased. It will start to conduct current and the voltage drop across the diode, it will become 0. Once the diode voltage drop across the diode becomes 0, then we will not get any output corresponding to the input waveform. So the same result we will be getting as we have obtained in the series biased positive clipper. So this is how the output waveform in the positive half cycle will look like. Let us consider the next half cycle, that is a negative half cycle. In the negative half cycle, again the polarities will be reversed. When the polarities will be reversed, the diode will be in the diode, it will be in the reverse bias. The diode, and as per VR, this is also in the reverse bias. So there will always be the potential drop across the diode and we will be getting the output corresponding to the input in the negative half cycle. So that was the biased positive clipper. Now, next question is what will happen if we change the polarity of this battery? we have negative positive. If we reverse the polarity of this battery in the same circuit, then what will happen? Obviously, the output waveform will be affected by the polarity of this battery. So let's see how by changing the polarity of the battery, the output waveform will be modified. Again, the same circuit, but now the polarity of the battery voltage has the polarity of the battery has been reversed. So the same series circuit we are again considering. Now during the again we have that same thing, we have the input waveform with positive and negative half cycles. During the positive half cycle, this diode, it will be reverse biased. As you can see clearly, during the positive half cycle of the input waveform, this diode will be reverse biased. And as per this VR, this diode is reverse biased. So during the positive half cycle, in the whole positive half cycle, this diode D, it will be in the reverse bias position. So whenever it is in the reverse bias position, it will again act as an open circuit, and all the voltage will appear across this diode, and there will be no voltage drop across R, so there will be no output voltage. So corresponding to input voltage, which is shown in this dotted line, there will be no output voltage. So the positive half cycle in the output waveform will be completely missing. In the next half cycle, that is in the negative half cycle, what will happen? This diode, it will become forward biased, and as per VR, this diode is reverse biased. So as long as the value of VI is less than VR, this diode, it will be in the reverse bias situation, and it will and there will be no output voltage. Whenever the value of Vi or the input wave voltage, it will exceed this battery voltage, then this diode, it will become forward bias. Once it will be forward bias, the current will start to flow in this circuit, and we will be getting the output across the resistance R. So after this value VR, once this Vi has exceed this value minus VR, we will be getting the output. So if we talk about the on overall output of this circuit, then we can observe that we will be getting the output only in this portion. The rest of the input waveform, the rest of the parts of the input waveform will get removed or will get clipped. Same happens, the same output, it happens with this shunt biased positive clipper with the reverse polarity of the battery. So let us consider that. During the positive half cycle, this diode will be forward bias, and as per this battery applied battery voltage, this is forward bias. So once this is forward bias, it will be short circuit, and there will be no voltage drop across the diode D. Therefore, there will be no output voltage. That is why we are getting no output waveform in the positive half cycle. During the negative half cycle, again the same thing happens. Whenever Vi exceeds VR, this diode, it will become reverse bias, and we will be getting the output waveform corresponding to the input. So whenever Vi exceeds VR, the diode D, it will become reverse bias, and once it becomes reverse bias, it will act as open circuit, and we will be getting the output across this diode D. So there will be some value of VO. For the rest of the portion of the input wave, we are not getting any value of VO or V output. So that was your positive, biased positive clipper. In the next is a biased negative clipper. Now let's see what happens here. This is a circuit. Again, we have this battery VR, which has been applied in series with the resistance R. During the positive half cycle, this diode is forward biased, meaning it will act as a closed switch. And as per VR, this diode is forward bias. Again, for both the in both the cases, the diode will be in the forward bias in the positive half cycle. So if it is forward bias, we will get the output across the resistance, and that output is shown here. During the negative half cycle, when the polarities will change, then this diode, it will become reverse bias. As per the input signal, this diode, it will become reverse bias. But as per this potential VR, battery potential VR, this is this VR, as per this potential VR, this is forward bias. So we have whenever Vi is less than VR, we are getting the output here. But when this Vi exceeds VR, in that case, this diode, it will become reverse bias and we will not be getting any output across the resistance. Next is a biased shunt negative clipper. Again, we have applied this battery VR potential across the diode D during the positive half cycle of the input. This diode, it will become, as n is connected to positive. So this diode during the positive half cycle, it will be reverse bias, and as per VR, this diode, it is reverse bias. So we will always be getting the output across this positive half cycle, and same happens in the negative half cycle. During the negative half cycle, this as per Vi it become forward bias, but as per VR it is still in the reverse bias. So whenever we have the value of Vi lesser than VR, this will be in the reverse bias situation, and we will be getting the output voltage. Whenever Vi exceeds VR, there will be the diode D, it will become forward bias and it will act as a short circuit, and we will not get any output across VO or across the diode. So the value of VO will be 0. So that is why this portion which is greater than VR, it will be clipped off. And same happens with the biased negative clipper. Now what we are doing, we are basically again reverting the polarity of this battery. So whenever we are reversing the polarity of this battery during the positive half cycle, again we will see what will be the situation of the diode during the positive half cycle of the input waveform. This diode will be forward bias, and as per VR, this will be reverse bias. So as long as the value of Vi is lesser than VR, this diode, it will be reverse bias. If it is reverse bias, then all the voltage drop will be across this diode D, and there will be no voltage drop across this resistance R. So that is why we will not get any output. So starting here from 0 to VR, we are not getting any of the output. Once the value of Vi exceeds VR, this diode, it will become forward bias and it will act as a closed switch. The current will start to flow in this circuit, and we will be getting the voltage drop across this resistance R. So therefore, after we have reached this value VR, whenever this input voltage exceeds the value VR, we are getting the output, and for the rest of the portion of the input positive waveform, that will be clipped off in the output. And if we talk about the negative half cycle, during the negative half cycle, when this polarity will get reversed, then this diode, when this polarity is reversed, then it will be reverse bias. It will be, this end will become negative and this will be positive. So this diode, it is in the reverse bias. As per this is also in the reverse bias. So if it is in the reverse bias condition, for whole negative half cycle, then all the output will be appearing across this diode, and we will not get any output across the resistance R. So the value of VO, that will be 0. So we are not getting any part of the input waveform reproduced in the output waveform. And again, the positive half cycle will continue. So this is the overall output, which will be the output will look like this. The overall output will look like this in the series biased negative clipper. And the same thing happens with the shunt capacitor. Now let us consider that also. During the positive half cycle, this diode is reverse bias as the n is connected to positive, and as per this is forward bias. So as long as the value of Vi is lesser than VR, this diode will be forward bias. If it is forward bias, there is no voltage drop across this diode, so there will be no output voltage. So we are not getting any output voltage. Once this Vi will exceed VR, then this diode will become reverse bias. Once the value of Vi is more than VR, this diode will become reverse bias. When this will become reverse bias, then we will start to get the output. So this is how the output waveform will look like. And during the negative half cycles, when this polarity will get reversed, then this diode is always forward bias. If it is always forward bias, then there will be no voltage drop across this diode and VO will be equal to 0. So this is the output waveform of the series and shunt biased negative clipper when we reverse the polarity of the battery. So that was all about the bias positive clipper. So I hope now you have understood how we can remove a certain section of the positive or the negative half cycle with the help of the clipper circuit. Now the fourth is a combination clipper. Now what is a combination clipper? Now if we have a requirement such that we want to remove the portion of both positive and negative half cycle of the input voltage. In that case, we will apply the combination clipper. So combination clipper, it is basically the combination of the positive and biased negative clipper. So we have now understood how the positive and negative biased clipper work. So combination clipper, as a name says, it is a combination of both, because in the bias clipper we have seen we are removing either small part of the positive half cycle or small portion of the negative half cycle. But if we need to do both ways, we need to remove both positive and negative half cycle, then we will basically combine the positive and negative biased clippers. So this is the combination clipper. So let us try to understand this. We have again the sinusoidal input wave. During the positive half cycle, the diode D2, it is always reverse bias, and D1, it will be forward bias. And as per VR, this is reverse bias. So the output waveform, once Vi will exceeds VR, then there will be no output across this VO. We will be getting output only when Vi is lesser than VR. So this is the output which has been reproduced in the output waveform. And once this and above this portion, when Vi is exceeding this VR1, this applied potential, that portion is being clipped out. Similarly, the same thing, it happens in the negative half cycle. So we can say that with the help of the combination clipper, we are able to remove basically the both positive and the negative half cycles of the input waveform. During the negative half cycle, what will happen? This diode, it will become forward bias and D1 will become reverse bias. And as long as we have the value of VR2 greater than V1, the value of this potential battery voltage greater than Vi, we will be getting the output. And once this Vi will exceed VR2, then we will not get any output waveform. So this is how the waveform will look like in the output corresponding to the input. So that was all about the combination clipper. So now we have studied basically four types: positive, negative, biased, and combination clipper, depending upon our requirement that what portion of the input waveform we want to remove or we want to clip on, we can use that clipper circuits. Now, as today we have discussed the clipper which are called as a diode clipper, in which we are using the diodes in the clipping circuits. So these circuits are very useful, but there are some drawbacks of the series and the shunt diode clippers. In series clipper, whenever the diode is in the off position, like whenever it is not conducting, right? So you can imagine, like if we have a positive bias clipper, I can show you. In the suppose positive, we have a positive biased clipper. Sorry, we have a positive clipper. Now, if this is not conducting, if this is off, then there should be no output voltage, because this diode will now be in the open circuit. All the voltage will appear across this diode, and there will be no voltage across the resistance R. So if we go like this, then there should be no output voltage. But it has been observed that in the off position, in the case of the high frequency signal, the transmission occurred through the diode capacitance and we are getting the output. in the series capacitor, when the diode is in the off position, there should be no output corresponding to the input. But it has been observed that in the high frequency signals, the transmission occurs through the diode capacitance, which is not required, which is undesirable. Due to this, this is one of the diode of the series diode clipper. Same thing happens in the shunt clipper. When shunt clipper, which is in the parallel with that of the diode resistance. Now, when the diode is off, then there should be the output. The output should take place, right? So there should be the transmission of the input signal to the output. But again, in the case of the high frequency signal, it has been observed that there is no complete output signal. There is some attenuation in the signal. So due to the diode capacitance effect, circuit operation adversely affects and the input signal get attenuated. We are not getting the full output waveform. So these are the drawbacks of the series and the shunt diode capacitor, especially in the case of the high frequency signals. So these are some of the references. So now I hope you have understood about the clipper circuits, and thank you.